Welcome to another episode of the Part 145 EASA training from Phoenix Way Academy. Hi, I'm Sarah.
Hi, and I'm Sam.
Well, in this episode, we will talk about 145.A.40 equipment and tools. Now, you might think, tools sounds simple enough, but this deep dive isn't just about, what's physically in the toolbox. It's about the absolutely critical role that every single piece of equipment plays in aircraft maintenance.
Right.
And all under these really stringent EASA Part 145 regulations. We're really going to get into why managing these items properly isn't just like a good idea. It's fundamental to safety and compliance.
That's absolutely right. If you think about it, managing equipment and tools correctly, it's the bedrock for ensuring an aircraft's airworthiness and, well, ultimately, the safety of everyone flying. It really hits the integrity of every maintenance task. So our mission today is to properly unpack the specific requirements of Clause 145.A.40. We want to reveal not just what the rules demand, but, the crucial why behind each point. Understanding that helps grasp how planes stay safe.
I like the crucial why. Okay, let's unpack it. Starting at the beginning, the foundation. We're kicking off with Clause 145.A.40. A. It sets a general but super important baseline. It states, the organization shall have available and use the necessary equipment and tools to perform the approved scope of work.
Yeah, this clause, like you said, it's the bedrock. And what's really key here is the word necessary.
Yeah.
It's not just a suggestion. It's a direct link. It means every tool must match the organization's specific approved capabilities.
Right.
And the exact tasks they're allowed to do. It's basically EASA saying if you aren't properly equipped for a job...
You don't do it.
Precisely.
Yeah.
You absolutely cannot touch it. It's a proactive safety thing, tying resources directly to responsibility.
Yeah.
So take an organization approved for heavy checks, maybe a C check on, say, a Boeing 737.
Okay.
To meet that necessary requirement, they must have very specific gear, like jacks designed exactly for that 737, engine stands configured for its engines, maybe even fuselage repair kits unique to that aircraft structure.
These aren't just nice to haves then.
Not at all. They're indispensable. Without them, that organization just doesn't have the necessary tools for their approved scope of work. Simple as that.
So what I'm hearing is it's not about having some tools. It's about having the exact right tools for what you're certified to do, tied directly to your approval.
You got it.
Okay, so if necessary is the base, what about when a manufacturer points to a specific tool? Is there any wiggle room? Let's look at subclause 1. That's clause 145.A.40A1. It reads, where the manufacturer specifies a particular tool or equipment, the organization shall use that tool or equipment unless the use of alternative tooling or equipment is agreed by the competent authority via procedures specified in the exposition.
Right. This one really hammers home the importance of precision. Manufacturers know their aircraft inside out, right? They design specific tools for specific tasks, specific tolerances. Using those ensures the work's done exactly as intended. It maintains integrity. Now, the default is always the manufacturer's tool. But yes, there is a path for alternative tooling.
Ah, okay.
But it's definitely not a shortcut. It needs formal agreement by the competent authority, your local CAA, basically. And it has to be spelled out really clearly in the procedure specified in the exposition. That's the organization's rulebook, their MOE.
So a serious process.
Oh, absolutely. It guarantees any alternative gives equivalent results, or maybe even better, without compromising safety one bit. Think about a specific pressure gauge. Maybe the aircraft maker says you must use this particular one for a sensitive hydraulic test. You use that one.
Makes sense.
Now, say the organization wants to use a different brand. Maybe it's easier to get hold of or cheaper.
Yeah.
They can't just swap it. They'd have to go to the authority with solid proof data, tests showing their alternative performs identically or even better. And all that evidence, the procedure, it all gets documented formally in their exposition. It's about proving equivalence, not just convenience.
Got it. So stick to the manufacturer's recommendation unless you have a really strong, documented, approved case for something else. Keep standards high. Okay, next up is subclause 2. Clause 145.A.40A2. This one talks about availability and, those tools you don't use every day. It states, equipment and tools must be permanently available except in the case of any tool or equipment that is so infrequently used that its permanent availability is not necessary. Such cases shall be detailed in an exposition procedure.
Permanently available. That means for your regular day-to-day maintenance, the tools need to be there. ready to go.
No delays.
Right. Avoids holdups. It's about efficiency, readiness, but the rule is practical too. It allows an exception for infrequently used tools. These are often, highly specialized, maybe really expensive items for rare repairs, things you might need only once every couple of years.
Yeah, owning everything could get costly.
Precisely. Doesn't make sense financially or logistically for every single organization to own every rare tool. But, and this is key, even these exceptions need to be formally documented, written down in an exposition procedure. That procedure has to explain how the tool will be accessed when needed and how you'll ensure it meets all the standards.
So even if you borrow it, it needs to be controlled.
Absolutely. Think of it like this. Everyday stuff, hand tools, torque wrenches, multimeters always on hand, ready. But imagine a super specialized jig, maybe for fixing a rare type of structural damage that happens, like once in a blue moon on one aircraft type.
Okay.
Owning that permanently, probably overkill. So the procedure might say they'll rent or borrow it from another approved place when that rare job comes up. But the plan, how it's sourced, checked, used, has to be clearly laid out in the approved exposition.
Okay, so it balances readiness for common tasks with cost-effectiveness for the rare stuff, but always with that documented procedure as the safety net.
That's the idea. Practicality, but never compromising oversight.
All right, shifting gears slightly. Subclause 3, Clause 145.A.40A3. This focuses specifically on base maintenance. The big stuff, it says. An organization approved for base maintenance shall have sufficient aircraft access equipment and inspection platforms docking as required for the proper inspection of the aircraft.
Yeah, this draws a really important line between base maintenance and line maintenance.
What's the key difference again?
Line maintenance is your quick stuff. Gate checks, minor fixes. Base maintenance, that's the heavy lifting.
Yeah.
Major checks, big repairs, modifications. The aircraft's usually in a hangar for weeks.
Right.
And for those really deep inspections, you absolutely need sufficient aircraft access equipment. We're talking proper inspection platforms, elaborate docking systems.
Why so crucial?
Because you need to get to every single part of that aircraft.
Yeah.
Safely, efficiently. These systems give engineers multi-level access. Think high spots like the top of the tail, the whole fuselage, under the wings, areas you just can't inspect properly from a ladder. They're vital for doing a truly thorough job, hands-on and safely. Picture this, a major C check on a wide-body jet. They're taking almost everything apart for inspection.
Wow.
An approved base maintenance org needs comprehensive docking. It's like scaffolding, but specifically built to surround the aircraft. Gives stable platforms at different heights, lets engineers safely reach the upper fuselage, wing edges, the tail section.
You couldn't do that with just mobile stands.
No way. It'd
Right.
be incredibly inefficient, unsafe, and just not good enough for the level of inspection needed for that kind of check.
So for base maintenance, it's about serious infrastructure. Specialized access is just fundamental for those deep inspections.
Absolutely fundamental.
Okay, that leads us nicely into Clause 145.A.40b. This gets right into the heart of tool control and calibration, precision and trust. It reads, the organization shall ensure that all tools, equipment, and particularly test equipment, as appropriate, are controlled and calibrated according to an officially recognized standard at a frequency to ensure serviceability and accuracy. Records of such calibrations and traceability to the standard used shall be kept by the organization.
Non-negotiable. Records of calibration plus traceability back to the standard used, that creates your audit trail, your proof. It shows the tool was accurate when it was used on that aircraft. It's like a guarantee of measurement integrity. Take a torque wrench. Seems simple, but critical. Every single one used on an aircraft engine, bolts, panels, whatever, must be regularly calibrated.
Checked against a standard.
Yes, checked against a known accurate standard to ensure it applies the exact force shown on its dial.
Yeah.
And the organization has to keep that calibration certificate. It shows it meets an official standard, like from a national lab, if there's ever an incident or an audit query about a fastener.
You pull a record.
Bingo. You show the record, proving the tool was accurate at the time. It verifies the process. Builds trust.
So boiling it down, precision, constant accuracy checks, and detailed records aren't just good ideas. They're absolute requirements for every tool. The silent promise of safety.
Couldn't have said it better.
Okay, now let's dig into the acceptable means of compliance, the AMC. Starting with AMC for Clause 145.A.40a. This gives us the real practical details on achieving that availability and managing that crucial control register. The AMC states, The organization must show that all tools and equipment as specified in the maintenance data can be made available when needed. All such tools and equipment that require to be controlled in terms of servicing or calibration by virtue of being necessary to measure specified dimensions and torque figures, etc., should be clearly identified and listed in a control register, including any personal tools and equipment that the organization agrees can be used.
Right. This AMC clarifies what show can be made available really entails. It's not enough to just say you have them. You need a system, a plan, inventory management, a reliable process.
And the control register is central to that.
Absolutely.
Right?
It's the core. And it's not just a simple list. It's a dynamic record. It tracks all tools needing control, especially calibration ones like micrometers, torque wrenches. And here's a point people sometimes miss, including any personal tools and equipment.
So a mechanic's own tools, too.
If the organization agrees they can be used for aircraft maintenance, yes, they must be on the register. And they have to meet the exact same control and calibration standards as company tools. No exceptions. Ensures consistent quality.
That makes sense.
So practically, an organization needs, say, a tool crib system, maybe digital tracking, something to ensure that a specialized puller tool for a landing gear job is definitely there when that job's scheduled. They must show they can do that.
And the personal tools.
Well, if a technician uses their own personal micrometer for critical engine measurement, and the company says, okay, that specific micrometer must be logged in the control register, it then falls under the company's calibration schedule. Same checks, same traceability. No tool gets a free pass.
Okay, that really underlines the need for a systematic, documented approach and how comprehensive that control register has to be, covering literally everything used.
Every single tool.
Right. Now let's look at the AMC for Clause 145.A.40b. This gets into the nuts and bolts of calibration procedures, labeling, and standards. First part, AMC 145.A.40b, 1. 1. The organization has a procedure to inspect service and, where appropriate, calibrate such items on a regular basis and indicate to users that the item is within any inspection or service or calibration time limit. A clear system of labeling all tooling, equipment, and test equipment is therefore necessary, giving information on when the next inspection or service or calibration is due, and if the item is unserviceable for any other reason where it may not be obvious. A register should be maintained for all precision tooling and equipment together with a record of calibrations and standards used.
Okay, this breaks down the practical side. You need a written procedure for regular checks and calibration, and a clear system of labeling. Think color codes, stickers, something that instantly tells the user, is this tool okay to use? When's its next check due?
Or if it's broken.
Exactly. Or if it's unserviceable for any reason, even if it looks okay, maybe it was dropped. That label prevents accidental use. And underpinning it all, a dedicated register, just for the precision tooling, with all the calibration records, including the specific standards used.
So it's the tool's history file.
Pretty much. Its life story, documented for safety and traceability. Imagine walking into the stores. Every precision tool, screwdriver, voltmeter, gauge should have a little label, tamper-proof. Shows last calibration, next due date, clear as day.
And if it fails a check?
It gets a big do not use tag, or it's physically quarantined. And all that info calibration dates, status logs centrally, database, register, whatever, makes it instantly auditable. Ensures only good, accurate tools touch the aircraft. It's a chain of trust.
Powerful image. Okay, and link to that. AMC 145.A.40b, 2, talks about how often to calibrate. It says, 2. Inspection, service, or calibration on a regular basis should be in accordance with the equipment manufacturer's instructions, except where the organization can show by results that a different time period is appropriate in a particular case.
This sets the default. Follow the equipment manufacturer's instructions for calibration intervals. They made the tool, they know best.
But there's an except.
Yes, there's flexibility.
Yeah.
An organization can use a different time period.
Right.
But they have to rigorously show by results. That means hard data, studies, operational proof that their alternative interval still absolutely maintains accuracy and serviceability.
But you need evidence.
Solid evidence. It's not about cutting corners. It's about justifying adjustments based on real-world data without compromising safety at all. For example, a manufacturer might say calibrate a certain diagnostic tool every year, but an organization uses it maybe twice a year in a very clean lab environment. They do internal checks, collect data over several years. If they can prove it stays perfectly accurate for 2 years under their specific conditions.
They might get approval for a 2-year interval.
They might, yes. But only with that concrete, documented proof presented to the authority. It has to be data-driven.
Got it. And finally, AMC 145.A.40 B3. This defines that term officially recognized standard. Crucial definition, it says. 3. In this context, officially recognized standard means those standards established or published by an official body, whether having legal personality or not, which are widely recognized by the air transport sector as constituting good practice.
Yeah, this is key for trust. An officially recognized standard comes from an authoritative body. Think national standards labs like NIST in the US or international bodies like ISO.
So, recognized authorities.
Exactly. And the crucial part is they are widely recognized by the air transport sector as representing good practice. It ensures calibration isn't just done to some standard, but to one the whole industry accepts and trusts for accuracy. It's a global benchmark.
Yeah.
Basically, if you're calibrating, say, digital calipers or avionics test
These
sets,
things needing high precision.
right, their calibration has to be traceable back to standards from bodies like NIST or its international equivalents. These institutions provide the ultimate reference points. They ensure that a measurement made in, say, London is comparable to one made in Singapore.
Consistency worldwide.
Precisely.
Yeah.
It's the backbone of global aviation reliability.
Yeah.
Everyone's working off the same trusted benchmarks.
Okay, that wraps up our look at the detailed procedures. From scheduling and labeling to sticking to those recognized standards, it's all designed to ensure every tool is fit for its critical job. So let's recap. We've really dug into EASA Part 145.A.40 and its AMC today. We've seen it's not just about having tools, but managing them meticulously. Availability, control, calibration. And this whole framework directly supports aviation safety, making sure everything is done correctly, building trust in every flight.
Absolutely. And, looking forward, considering how strict these rules are for physical tools,
Yeah.
how might the rise of digital tools, augmented reality and maintenance, how might that force us to rethink availability, calibration, even control in that digital space? Something to ponder.
That is a fascinating thought for the future. Definitely something to think about. Well, in the next episode, we'll cover the 145.A.40 components. You can follow us on social media under the name Phoenix Way Academy. Thanks for listening. Stay safe and stay informed.